Moving on, I've kind of put it in here with new and delete, and really I should update this with pointer notation, and I hope to. We've got pretty much an example that we've seen previously, and we'll just go through this one more time, and we will add the pointer notation at the very end. So what we're doing here is similar to what we have seen previously in our other examples. We have we have a combined assignment here in line number 8 because it dawned on me that we hadn't done this yet. We've got a pointer called sales equals null pointer. I don't believe that we have done that in one line previously, so I wanted to double check and make sure that we did that. Here, I've got a bunch of double variables that we're using here for total and average, because what we're going to do is take an input from the user, create an array of doubles based on that input, and then do math based on that. So at any rate, once we have from the user our number of days, we are going to create dynamically a double array of size however many the user inputs here. And remember that that new keyword indicates that this is something that we can delete when we're done. We can dereference the RAM, we can dereference the memory. I'm going to say RAM incorrectly here, potentially all day, because we just got done recording another podcast talking about RAM. So there's your sales, remember, which is a pointer to a new double array. So once we have received how many days we are getting values for, we will in fact receive those values. And here, this is the wrinkle we're going to change later on. We have the traditional subscript notation here for arrays. So here is sales at subscript count. And this is the thing that we are going to change. But I just want to go through and show that this works. So it's already running. I'm going to get 3 numbers, 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6. And here we get our average equals total divided by number of days, which we know we can already do. We've created this little for loop that goes through and total plus equals sales at subscript count. So again, we're doing that normally with the traditional array subscripting that we have seen. This is the difference here. The pointer notation we're going to use to read values back out of our sales array. So here I have the exact same for loop that we have used these other 2 times. So I'm trying to reuse the code here. It's legitimately all I did was copy and paste this for loop and paste it back down here. So this time we are going to output the result of, so that's what is happening here inside of the parens, right? So what we're saying is here is sales plus count. So that is sales, the pointer for sales, because that's what's happening here with the asterisk notation, plus 0 the first time through. So we're going to take that and go to the first location for our array based on that pointer. The next time through, it's plus 1, right? So that means we're going to go to the location of the sales array based on that pointer, and we're going to move up to the next pointer reference, up to the next reference of the next. In this case, it is a double in that array. So here, we're just going to go ahead and run that. I'll use the same values. 3 figures, 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6. And here is our new output based on the pointer notation. So this little code snippet right here is something that you could copy And you could use for the end of chapter exercises, because let me tell you, they show up this way. So here is traditional. Can I call it traditional? I think it's traditional. Traditional array notation, and here is the new wrinkle, and that is pointer notation for iterating through our array. So it's, come on, there we go, right here. So asterisk, and then in parens, the name of our pointer plus count, because that count is going to get us to the next pointer, the next pointer, the next pointer, the location, the reference of the next value in our array.